The first talk I will talk about how to make games with Qiskit. So my name is Huang Junye, and I'm a Qiskit Advocate. So the first slide, I'm going to give some introduction about myself. As I told you, I'm a Qiskit Advocate, and I went to the Qiskit camp in 2019. And I also organized a Qiskit hackathon in Singapore last October. And I know that Sam and other people that are also organizing a Qiskit hackathon in India. So we are very excited. And all these meetups are trying to teach people about Qiskit so that you get prepared and then you go to hackathon in India later, maybe end of March. So I'm also a PhD student at National University of Singapore. So the reason why I'm giving a talk about Qiskit game is that since I joined the Qiskit camp, I have made a few games with Qiskit. So these are the projects I have done, and I will also cover them in today's talk. So I make a quantum version of Pong, which uses a quantum circuit to control the state and position of the paddle on the right. And later, I also use the Pong to make an actual physical arcade machine. And I also make a game with some other people about a quantum circuit puzzle game in a Minecraft-like games. And the last game I will talk about is Gogogiver. It's a quantum game that tells you a few different folk tales. So let's get started about the game. Why do you want to make games or play games? The first reason is very straightforward, because we play games because the games are fun, period. And the examples are, all the games you play, mostly are just play for fun. So you can play Mario, Pokemon, League of Legends, Minecraft, or Fortnite. The games can also be cool. Games are used to demonstrate technological advances. A very famous example is the IBM Deep Blue. The Deep Blue in 1997, I think, was the first computer to beat the world champion of chess. And you can see in this photo. And that's not the only example. IBM Watson also win the world champion for Jeopardy. And more recent example includes AlphaGo, a machine learning algorithm, beat a world champion for Go, Japanese like chess-like games. But it's not just for board games. Recently, a different version of AlphaGo is developed to play StarCraft. And he also won against the world champions for StarCraft. So games are cool, and they are using to demonstrate technological advances. And that's also one of the things we want to try with quantum games. We want to maybe show games about that you can play in quantum computer and show the powerness of a quantum computer. And games can also be educational. They can teach you something. For example, SimCity. It can teach you how to do city planning, how to arrange economics and the resources of different things. Other examples include Oregon Trail, which is a very old game in the 1970s to teach the American history of people migrating to the West. And you can also play other examples like Roller Coaster Tycoon or Civilizations. And games can sometimes be directly useful, not just teaching you something, but using it to do something very useful. A prime example I put here is a game that helps you to, it's an online citizen game that lets the player to play how to fold a protein. And the scientists can use this data of the player folding the protein structure and verify them to use it in real research. And another example is that Microsoft has a very old game since 1980s, and now they still have it very updated. That you can use a flight simulator like a pilot. So that's the reason we want to make games. They're fun, they're cool, and they're useful and educational. And the main topic about today is that not only we can do the thing I mentioned to you in a classical computer, even though nowadays the quantum computers are still in an early age, but we can already play games and make games for quantum computers. So as I promised you, I'm going to show you this game, Pong, I made in the Qiskit camp last year in March. So this is a quantum reimagination of the classic Pong game. And I like this game, and the idea we make this game is that most people have played the classical Pong game, so they are very familiar with the game. But in the Q Pong, we are bringing this familiar setting, but to explore unfamiliar concepts like superposition and measurement. So right now, give me a few seconds. I'm going to run the game for you. Okay. Hello. Can you guys follow the slide? I'm going to share the screen for Q Pong. Okay, takes a while. Okay, good. Can you see the game?
We can see the game.
Yep, okay. So let's see which difficulty level you want to try. Let's try expert. Okay.
Go with expert.
So as you can see, on the top of the game is just like a Pong game. So you say the game I designed in the sense that on the left is a classical computer, which is just like a classical Pong. That is just a computer AI. And on the right, you see this part is the state vector of these 3 qubits quantum circuit. Right now, I'm not putting anything. So the state is 0, 0, 0. And here's the quantum circuit that I can change. If I'm changing it to, for example, here, Qiskit. So you see it changed to 1, 0, 0. So here the qubit is from 0, 1, 1, 2. So you see 1, 0, 0. And if I want to put a Hadamard gate, you're going to see a superposition between 1, 0, 0 and 1, 1, 0. So now the game, you can see, let's try to play. So that's a basic thing. You can have an X gate or Hadamard gate. And let's see if I can beat the classical computer. Okay. Let's see. Yeah. Good. So you can see that when the board triggers, when it reaches to the quantum pedal part, it triggers the measurement. And only one of these 2 outcomes will be measured. So if you want put more Hadamard gates, you have more possibility, but each of the pedal will have lower possibility. That was very lucky. But if you put more Hadamard gate, you have more different possibility, but each of them will reduce probability. So you have a lower chance of success like this. So let's try. Okay, let's see. Wow, today I'm very lucky. So this game is in the winning score is 7, so we are almost losing. Let's see. Let's see whether we can keep. Wow. Okay. I think we just lose. Okay. So when if you lose, you say you see the screen of classical computer still lose over. Okay, let's go back to the slide. If you win the game, you get a bonus of seeing the first quantum supermassive. Oh, sorry. Can you see the slide again? Hello?
We can see the slides.
You can see the slide, right? Okay. Okay. So this game was shown in a museum, and this participant, Andy Varady, was the first person to beat the game, to beat the classical computer. And at the time, I was sending this tweet to say that he was the first man to demonstrate quantum supremacy in human history before Google. That was in April. Okay, so I'm going to show you the next game I made with IBM Quantum Developer Advocate James Weaver. So in this game, you are going to see a maze of different escape rooms, and inside there you have different puzzles made of quantum circuits. And in the world looks like Minecraft in an open source Minecraft platform called Minetest. So I'm also going to go ahead and give you the demo. Okay. Can you see the game?
We can see the game.
Okay, good. Sorry. Loading. Okay, so when you go inside this room, when you start a game, you first in this room that you can see different kind of quantum gates. You can go and check the information, but that's too easy. So we can just go ahead and enter this place to play the game. So here you see, this is 1 out of 16 escape room we made. And you can see that on the wall is the answer to a puzzle, is the quantum state that you want to reach by putting gates in this quantum circuit in order to get to the next room. So we can go to here in the chest, get this block, which is the X gate. So the first stage is very easy. You just want to change the initial state 0 to 1. So all you need to do is just to put the X block. So you get 0 to 1 and you go to the next one. Okay. So let's see the next. So the second puzzle is, so the first few stages are very simple because we wanted to attract more beginners. So we are taking it slowly. You see that in later escape room that the difficulty is going to be a bit more difficult. So let's see, here is simple. We just need to change from 0, 0 to 1, 0. And you see the color of the qubit is color coded. So we just need to change this. And you can go to the next. Okay, here is 0, 1, 1, easy, the 0, 1, 1. Okay, get this my gate. So here is a superposition. You see, what we want to do is 0 and 1, and this boxes shows the liquid level, which represent the probability of the state measure, the result of measurement. So you see here is half empty, half filled, means 50% of 0 and 50% of 1. And here is also very easy because we are trying to teach you something. So here you just need to put the Hadamard gate. Okay, next. So I'm going to play until stage level 5, and then we're going to go back to the slide. So here is a bit tricky. You want to have 0 and 1, but here is a minus sign. And you can see in these boxes that it shows us the face of the qubit. You see here is pointing that side, and here is pointing the other side. So if you just do a normal Hadamard gate, you see that here is 50%, but the arrow is not the same as here. The 0 is correct, but the 1 is not. So what we need to do is to put here. Then you see in one is reversed. Okay, so this is the last one I'm going to show you. So here is looks exactly the same as the previous escape room, but instead of having an H and X gate, you only have the H and Z gate. So here trying to teach you the differences of X and Z gates. So you can do the same here, but in the previous game, in the previous level, we put a Harama gate here and X gate here. In here, you need to do the opposite to reach this. Okay. Okay, let's go back and see the slide. Okay, any questions so far? Do you take questions? Do you see the slide?
Not the slides, not right now.
Can you see the slide?
Is this the slide? The Qiskit block slide?
Yeah, okay. So
Yeah.
if you, for those of you that you have the live slide, you can click here and click Qiskit box. It brings you to the GitHub of this game. And if you want to play this game, you can just download, follow the instruction here. You can download the mind test available in many different platforms, Windows, macOS, Linux. And once you download that, you just need to go to a content and you can search for Qiskit blocks and you install the game and you can play it. Okay? Okay, good. So now we are going to talk the third game that I made. And in this game, I went to a hackathon in October at CERN, and I tried to challenge myself because the game I made before was more a traditional kind of game. So this time I wanted to challenge myself to make a completely different kind of game, which is a storytelling game. And with a bunch of people, we brainstorm and we come up with this game that have a multiverse with 3 different stories of fairy tale that involve a wolf. So we named the game Gogogiver, which is a multiverse of wolf. And you play as the wolf, and you start with one wolf, Peter and the wolf. And in order to eat the Peter, which is your goal to win the game, you have to transfer to the different universe, this little red hood, or the 3 little pigs to pick up some quantum gates. And then the probability of you eating Peter is determined by a single qubit and the measurement outcome of 1. So you need to pick up a few quantum gain and put it into a quantum circuit to make the outcome of eating Peter to be 100% instead of 0. But I'm not going to show you this game here because it's a bit slow. It's a text-based web browser game. So if you want to play it, you can click here to the GitHub and you can play online here. So maybe I just show you 1 minute. So it's text-based. You can see the storytelling. Yeah, okay. Any questions?
Any questions?
No? Okay, so how are we doing this time? We are about 20 minutes, right? Okay. So you want to play even more games? This slide shows you all the other games that people make with Qiskit. This first one is a very special one. It's not a computer game, it's a card game that you can play with other people, and each of you is a qubit. And you want to turn yourself from initial state 0 to 1. And the card that you have in your hand is some quantum operations, swap gate, X gate, H gate, and Z gate. So each you take turns to play the game. You can put the gate to yourself or to put to other people. And at the end of the game, you get a very complicated quantum circuit and put into a program, and you send to the actual IBM Qiskit the quantum hardware, and you give you the results to determine who is the winner. And there's many other more games you can see here, and you can also click these links to go to the GitHub repos. And if you even want to play more, I make a repository to contain all of the quantum games that I know. Not all of them are made with Qiskit, but most of them are. You can see it's a group in under different years in chronological order. At the beginning, there was not many games, but if you see 2018 and 2019, there's many more games are coming up. So if you want to try or maybe you want to see how they get made, you can go to this GitHub repository to check them. Okay. So if you get hooked, let's try to see how we can start making some games like Pong or the Qiskit blocks. So if you want to make games, you first need to have a game engine. And Qiskit is made in Python. So if you want to make a simplest game, you should use game engine that is based on Python. For example, Pygame or this Cocos or Tinketer, which is a UI, but you can also make some game with it. If you use Python-based game engines, it's very easy because you can directly import Qiskit in the game. But these game engines are not really good for making very complicated games. So you can also use game engine that's not in Python. For example, Unity, Godot, Mindtest. This was the game engine used for the Qiskit blocks. You can have other things, or Phaser, which is based on the JavaScript. You can host the game in the web browser very easy. And Twine is what I use to make the Gogogiver. But because this game engine doesn't use Python, so you cannot directly import the library, Qiskit library. So you need to use something called Flux in Python, and it hosts a local server and you need to write some Qiskit API in the programs so that you can communicate between the game engines in different languages by sending HTTP requests to the Flux servers to run the quantum circuit. So because of the time limit, I'm going to show you just very quickly how you make a game like Pong, because you use Pygame, so it's easier. So first we can have a look how the Pong looks like and what we need to make. So you can see in here is the layout of Pong. On top is just a classical Pong. So I found some open source Pong in Python, and you can copy this part. And on the bottom is a quantum circuit. And there's also some open source GitHub repository in Pygame to incorporate this part of quantum circuit and how to input a quantum circuit and generate a quantum circuit object in Qiskit. So this is the part that was mainly what we made during the hackathon. So here you see we have 8 different quantum states, and the transparency of the quantum paddle is determined by the measurement probability of the quantum state. And also there's one part that distinguishes before measurement and after measurement. Before the measurement, you allow superposition. So in Qiskit, you can use a state vector backend to run this quantum circuit to get the measurement outcome probability here. But after the measurement, the state will be collapsed and only one state is allowed. So you use Gaussian simulator, which simulates the actual hardware. So this is the main part I'm going to show you in the code. So give me a second to run the Visual Studio. Okay, can you see the code? Yeah.
We have a question over here. Do you have time for a question?
Can you see the code?
We can see the code. Do you have time for a question?
For questions? Yeah.
Yeah. One second.
You showed earlier, blocks game is probably done in Unity.
What is the question?
Okay, can you speak up?
The blocks game, the interface is done using Unity or Flash. Unity can
Is the game implemented on Unity or on Flask?
Okay. Okay, let me go back to the part of game engine. So Pong is not in Unity. It's used Pygame, which is a Python. Can you see the slide again? Yeah, so I use Pygame, is the game engine in Python. But as I showed you in the beginning about my self-introduction, I also made the arcade version, which is use Unity to make the game. So I make two versions. So if you want to use Unity, you will need to use the Flask server, which is I'm not covering today, but if you're interested, you can write to me in Slack and I will explain to you how to do it. Okay, so let's go ahead and see the code. I don't know, the Zoom at 40 minutes limit, right? So I think I need to get going. Okay, do you see the code?
Yeah, we can see the code.
Yeah, okay. So just give you a quick scheme of how the code looks like. So in the beginning, there's a bunch of things. So this is the folders. So it looks very complicated. There's many other stuff that is going on because we need to handle the graphics and also the controls. But that is not the key. This is essential for all games. But now I'm going to show you the what is so quantum or Qiskit about this. So I'm going to show you the core part of the Qiskit, which is the state vector grid I use. In the game is on the right, you see the quantum paddle. So in here, you see these two functions. I have one function to do the paddle before measurement. And you must already learn how to use Qiskit, right, in earlier talks. So you see the way I do it is I get the backend from basic air, get backend state vector simulator, which will give you the absolute state of the qubit. And you can run the simulator in the given the circuit in this backend, and the short number is by default, I think 1000, and you get the simulation result. The quantum state is extracted by this command get state vectors. So this state vector, because for 3 qubits, you have 0, 0, 0 to 1, 1, 1. And here in the loop, I'm setting the transparency of the quantum paddle corresponding to each state based on the probability of the quantum state. And here I'm running in a different backend. And in this backend, you can do a measurement. And because of measurement, you get collapse of the quantum state. So you only get one outcome. And based on that outcome, I will only show the quantum paddle corresponding to that. So I also make a Jupyter notebook demo to show this part. So I'm going to show you here. Can you see the Jupyter notebook? Yeah?
Yeah, just pop up.
Yeah, okay. So this is a little Jupyter notebook I make to explain the part that I used. So first is just to import some custom game library that I made. And okay, let's just go to run it. So the beginning is a bit, I'm not going to cover how to make the circuit grid, but it's similar to what you showed before in the earlier talks. So I can compose a quantum circuit. Here I have 3 qubits, 3 classical bits. and I can add Qiskit. So just ignore this part because it's a bit too much. So here I'm just making some kind of circuit with some Harama gates. So this is part I want to show you. So you see, this is the function I explained to you before. You do a simulation using state vector simulator. And let's run this quantum circuit. And you see that I get a list of probabilities from 0, 0, 0, 0, 1 to 1, 1, 1. You see only 0, 0, 0, 0, 0, 1. And I'm not sure what this is, but there's 4 different probabilities. And I also make this matplotlib hack to show you approximately how it looks in the game, but rotated by 90 degrees. So you see that based on this measurement, I get the probability of a quarter in this 4 states, and I can draw this in transparency to represent the measurement probability. And after the measurement, I run it in the same circuit, but in a different backend. And in that case, I only do a single shot measurement. So you collect the quantum state, and you only get one outcome of the state. And let's see what is the result. So you see the result is 0, which means 0, 0, 0. So you see the result is this. So that's how I make the game to combine the game part and the quantum computer backend. So that's just a very quick demo of showing you how to make a quantum game. So there can be many other ways of making it, but usually in for most of the game that I make so far is based on a quantum circuit. You play something in the game that manipulates the quantum circuit and give you a certain effects in the game. In here is the transparency of the location of the paddle. So that's how we make a quantum game. So this is the first part. The first talk I'm going to talk about the quantum games. Let's see, do we have time to take some questions? Seems the video is not stopping yet.
Questions? Specifically for this slide. Are there any questions? Anyone? No? Nothing? Oh, we have one question.
Good. Yes, Mike. Can't really hear.
Same work using Python. I think you have used Python, right?
Sam, can you repeat the question?
Can you implement the same using Python?
Python?
Yeah.
I've never tried. So you wanted to use in C++, is that?
Python.
Right? Python in C++.
Yeah. So he hasn't done this.
I've never done it, but I was trying to do it. Might be a good idea because some game engine is like I think Unreal game engine. Those are make very big, and games that you play on Xbox or PlayStation, they use C++. So it would be nice to have that. So this is something I've been trying to work on because most of the real game engine doesn't use Python. So one of the solutions I showed you was this using a Flux server. So this, you can do it on your local computer, but if you want to ship a game, if, for example, I was trying to do a Pong to install on an iOS device, this way doesn't work because you cannot run a local Flux server on your iPhone. But one other way to do it is if you go to some cloud computing platform, you can put a Flux server. So your game is locally, but the quantum part that is the Flux server hosting Qiskit is in the cloud. So you can play the game locally, but it sends the calcium code, which encodes the quantum circuit to the cloud. This is the way we done it with the Qiskit blocks. So you download Qiskit blocks, the Mindtest game. The Qiskit doesn't run on your computer. You run the game on a computer and it sends to a remote server. Other ways to do it, I was trying to do, there's some other packages to integrate Python and C# because Unity is a very popular game engine, but there's many other caveats, it's really difficult to make it run very stable. So yeah, but that's a very good question because this is something I've been trying to work on because Pygame really sucks. Like the Q-Pong is such a simple game, but it consumes so much memory to run it. So yeah, it's not the best language to develop game. Okay. Any other questions? No? If not, then we stop this call and then we are going to restart the call again because the Zoom has a 40 minutes limit. I'm going to give you a second talk. Okay?
Okay. Then let's join back again in 2 minutes.
Okay.
Okay, great. Thanks.